Hey folks, Aaron Beyer with Gleaner Combines, and if there's one word that I hear consistently when I go to farm shows and talk to owners of competitive combines, it's T-Rex unloading auger. And I tell you what, I can probably attribute that to one individual, and I won't say his name. But here's the thing, guys. The reason that we're different is because we have a lot of different priorities. Not only is it the fact that we're trying to just unload the grain out of the grain tank, we're also trying to do it at a fast rate. We're trying to do it with less damage to the crop. And we're trying to do it with less horsepower, so you're using less fuel and you're using less horsepower that can be better used to the processor. So I wanted to kind of walk through some of maybe the myths, if you will, or misunderstandings, or just some of that knowledge gap of why we use the angled unloading auger that we do. We call it the direct flow unloading auger, and really look at it in a real world situation that we put it in kind of a backwards of a good, better, best, put it in some of the bad situations you might see in the field, and really look at the numbers as far as what the clearance is from a grain cart and the unloading auger, and how to set it up best to be able to unload on the go and do it comfortably, and understand that there's a lot of benefit to the angled unloading auger, and this is why we do that, and the priorities, and maybe that we're overlooking the obvious and really can really get past that little bit of unease that we're worried about when we take a look at that unloading auger. So let's go ahead and take a look first and kind of see how we want to kind of situate the machine to the grain cart, and then look at the clearances that we have at that point. So let's follow me back here and let's take a look. So if you look how the unloading auger and the combine is positioned to the grain cart, what we're trying to put is that angle, the confluence of the spout and the unloading auger, right at the sidewall of the grain cart. Now the reason that we can do that is you can see that spout isn't just dropping straight down into the grain cart. We actually throw about 2 or 3 feet beyond the end of the unloading auger so we can hit the center of the grain cart and still keep that maximum amount of clearance. And we can also see the amount of clearance that we have above the grain tank as well. So let's go take a look at the tape measure and see what we got. So in this scenario where we're nice at the best scenario, right? We have flat ground, we have the combine and the tractor and the grain cart all on the same plane. We have a maximum height of 15 feet 3 inches. Now with our 11-foot side on the grain cart, that gets us a clearance of about 4 feet 3 inches between the crux of that unloading auger and the sidewall. So what we want to do is really, again, put it in some bad situations that you might see in the field, some terraces, some washouts, some things that might put you in a little bit of a concern as far as operating the machine in the field and the differences you would see with a turret unloading auger spout. All right, so here's our first situation that we're unloading in the field, maybe on the go, in a bad situation, maybe not the greatest situation. We have a bit of a terrace here. We've got the outside wheel higher than the inside. And we're tipping that unloading auger towards the grain cart. Again, this is that first situation. This is, again, a lot of guys get concerned, maybe a little squeamish in this situation. So let's actually look at the metrics, look at the numbers, and see what the difference is as far as if we're on flat ground versus on this first level of a low-lying terrace. So again, you can see that the unloading auger spout, it is closer because we are tipping towards the unloading auger. And you can see that with our full 14-foot 8-inch clearance between that edge, that confluence, the crook of the spout to the unloading auger where we want you to position it, we've got a 3 foot, about 3 foot 5 inch clearance between the end of that unloading auger and the sidewall of the cart. Now again, this is that first level, but I think we can make this a little more extreme if we try. All right, so here's our next situation, and you can kind of see we're trying to set up something just to really show you the extremes. And so here's the next situation that we've got. The combine's on a plane at an angle in comparison to the tractor, to where we've got it on a flat surface and the combine's angled. And if you look at the distance and the clearance, we still have a pretty good clearance. We've got 14-foot 2 from the crux of the spout down to the ground. And then we've got still that 3-foot clearance between the angle of the unloading auger and down to the sidewall of that grain tank. So again, a little worse of an experience, but still plenty of clearance to where, again, if you're unloading in some situations, you really got to assess where you're at. But in a less than ideal situation right here as far as unloading on the go, and we still have 3 foot of clearance. We're trying to find the worst case scenario for you folks, just to show you what, you know, again, we're trying to get over that little squeamish feeling about the unloading auger, the clearance and all of that. And you can see here, I think we found the worst case scenario. Now we did have to kind of set this up a little bit, but I think everybody has had kind of experienced this to where you're unloading on the go, you get to the point, even on a turret unloading auger, to where the spout dips down into the grain tank or grain cart, and now you're in a kind of a situation. Now, what do? Now, on a turret unloading auger system, you could try to fix the problem by swinging the unloading auger in, but ultimately what you've done is now you've made the situation worse. Because if you've ever watched an unloading auger, a turret unloading auger swing in, it doesn't go just straight back as it comes back in. It's got to drop down in to go into the cradle. Now there's a distinct difference on how our unloading auger system swings back in that it doesn't drop down, it actually raises up. So in that turret unloading auger, when you're trying to get that spout out of the grain cart, you've got to back both the tractor and the combine at the same time, kind of a dance between the two to get you out of a bad situation. With a Gleaner combine, you simply swing the unloading auger in. So if Jason goes ahead and starts that up and swings that in, you're going to see exactly what I'm talking about. So again, now we've got the graded clearance to be able to pull the grain cart out and be able to get us back out of that bad situation. Here's the other thing that you can kind of see too, is that we're situated with the grain cart right next to the combine. Again, if you're unloading on the go, you get a little antsy, you swing the unloading auger in a little quick. On a turret system, you're going to catch the back corner of that grain cart and you're going to rip the spout off. Gleaner combine, you can see you've got the added clearance to where you can swing the unloading auger in with the tractor and the grain cart right next to the machine, and you haven't done any damage. So we spent some time talking about all the bad situations you can get. So what are the reasons why you want a direct flow unloading auger from a Gleaner combine? Well, there's really 3 main reasons. The first off is our unloading auger rate. We have an average unloading auger rate of 4 bushels per second. And that's strictly because we have all of the grain pushing down on the unloading, on the drag auger, the cross auger along the bottom of the bin, and then it swivels, it goes right out to the swivel unloading auger as a direct flow into that unloading auger. And it's average, 4 bushels per second average. That means from completely full to completely empty, you're getting that 4 bushels per second. Now, on the other machines, when you look at their rate, that's a peak unloading auger rate. That means when that grain tank is full, they can achieve that fast unloading auger, but when it starts to drop as far as the level, then that starts to slow down. Again, 4 bushels per second unloading auger rate, and that's for the complete grain tank on a Gleaner combine. The other advantage for the direct flow unloading auger system is the less damage to the grain itself. We've done so much work to be able to create the best bin sample in the industry. It would really be a tragedy if we damaged it by pushing it through right angle turns of a turret unloading auger system. With a direct flow unloading auger, it is a gentle, gradual increase in height. We raise it up gradually, really gentle on the grain, no right angle turns, no boiling point, and it unloads directly into your cart with less damage. Then finally, there's the point about using less horsepower to do the unloading. Because we have the direct flow, we have a straight through design, there is no excessive horsepower use because we have right angle gearboxes at the bottom and at the top of that turret unloading auger system. So again, we're saving fuel and saving power to be able to put it where we need it the most when we're harvesting, and that's into the processor. So again, these are the advantage to that direct flow unloading auger system that a lot of people like to knock us for, but understand with Gleaner, we have other priorities than just getting the grain out fast or unloading it fast. We want to make sure that at the end of the day, you're creating a better bin sample, better grain quality, better fuel efficiency, and really achieving a better harvest.